Read through the vocabulary, the I can statements, and the why. Please do so now. Also pause the video to complete the 2 warm-up exercises. When you finish that, read through the definition and we'll get started. All right, so the first trinomial factors as a perfect square binomial. Remember, a perfect square. A square looks like this. Both sides are the same. So I'd have an x minus 6 times an x minus 6. This is not the case here. This would be a rectangle. If we decided to use a quadrilateral to model it, I have a side that's x plus 3 and a side measure that's x minus 2. And today we'll be talking about 2 forms of an equation of a circle. The first one is our standard form, and h comma k is the center of our circle, and our r squared here, radius is, the length of the radius is r. And if we have just an x squared plus a y squared equals an r squared, then we know the center is at the origin. So the first one we could do pretty quickly. Our center is at the origin, and our r is going to be the square root of 16, or 4. Here our center is at negative 2, comma 3. R is the square root of 20, but we would simplify that to 2 square root 5. Right, there's 2 for you to try. So pause the video and give these a try. So here the center has the coordinates 4, negative 8. And if you go out in any one of these 4 directions and hit the circle here, our radius would be an 11 minus a 4, which is 7. Here our center is at 0, 5 halves. Our radius is the square root of 9/4, which would be 3 halves. Okay, our next exercise is going to be to write the equation. So we take our information, x minus 3 squared plus y minus a negative 5 squared, so that would be plus, equals r squared. X minus a negative 1, quantity squared, plus y squared equals diameter here, be careful, so radius would be 12, so this would be 144, or r squared. This next one, we have a circle with a center at 4, negative 1, so that's what we'll start with. X minus 4 squared plus y minus a negative 1 squared equals r squared. And now we'll use the extra information, and it goes through points 5, negative 7. So we substitute in 5 and negative 7, and then we solve for r squared. So this would be 1 squared plus negative 6 squared is r squared. R squared is 37, and then we take that and put it in here, and then we've got our equation. X minus 4 squared plus y plus 1 squared equals 37. Now we have a circle with a diameter of endpoints. So this one's going to require a bunch of work. We need to use this information to get both the center and the length of the radius. How I would start this problem, though, is I would start by stacking these 2 points one on top of the other. So we keep the x coordinates and y coordinates organized. Let's maybe start with the length of our diameter, which is the distance between these 2 points. Just going to be the difference in the y coordinates squared plus the difference in the x coordinates squared. X's, and here are my, here are my y's. So the length of my diameter is -6 squared plus 12 squared. This is the square root of 36 plus 144, which is the square root of 180. We simplify that a little bit. We will get, think of this as 36 times 5. So we'd have 6 square root 5. That's the length of our diameter. So that means our radius would be half of that, or 3 square root 5. All right, so we have at least the last part of our equation here. We can get our r squared. Now we need to find the center, which is the midpoint of a diameter. So here we take our 2x coordinates and find their average, or what the middle point of the x coordinates and the middle or midpoint of the y coordinates, and so on. Then I would have 2 over 2, 4 over 2, 1 comma 2. So here's my center. And now I just put all of that together into the formula. X minus 1 squared plus y minus 2 squared equals r squared. So that's 3 times 3 is 9 times 5 is 45. Right. Our next example asks us if a point is on, in, or outside of the circle. And again, our jumping off point is going to be our equation of the circle. So we're centered at the origin. So this time we have x squared plus y squared equals r squared. And like the previous example here, C, in example number 2, we're going to use that point and put it into this equation. So I have -3 square root 2 squared plus 5 squared. How does this compare to 49? So this is very similar to the problems we did with our triangles. Taking the 3 side lengths, setting up that Pythagorean theorem relationship, and seeing if it is satisfied. And if not, which inequality played out told us whether we had an acute or an obtuse triangle. So here, this is going to have the same setup, and it's going to tell us whether we are on the circle. That means we get equivalent, right? That point satisfies that equation of the circle. If we get that the point has less than our r squared, so we're less than r squared, maybe I'll write that too, equal r squared on the circle. Less than r squared, we'd be in the circle because we wouldn't have enough to get to the distance of a radius, right, to get to the end of the circle. If it's greater than r squared, then we're outside of the circle. We went beyond the radius squared. Again, it's super important that you put this in your calculator correctly, or that you do it by hand. So I'd have -3 square root 2 times negative 3 square root 2 plus 25. How does that compare to 49? A negative and a negative would be a positive. So I have 9 times 2 plus 25. How does that compare to 49? Well, this is 18 plus 25. 5 and 8 is 13. 2, 3. 43 is less than 49. So this point is inside the circle. Okay, I'll do another one, and then you are going to do one. Okay, the circle has a center now at 2, 4, with a radius of 3 square root 3. Well, we need to square that. And does 6, 3 lie on the circle? So I'd have 9 times 3, or 27. Here I have 4 squared plus negative 1 squared. This would be 4 plus 1, which is 16 plus 1. How does that compare to 27? Well, 17 is clearly less than 27. So this point also is inside the circle. Let's go ahead and you give it a try. And this point is on the circle. Right, our next form we're going to look at is called the general form of the equation of a circle. Not as nice and tidy as the standard form. If we go way back, this is the idea of, we had our quadratic. Remember, we had 3 forms: the vertex form, and then our factored or intercept form, and then our standard form. And the one that was the easiest for us to just start graphing was the vertex form, because we got the vertex, we used the pattern, adjusted it if we needed to, and we could produce our graph. Just like that, this general form is not user-friendly like the standard form of the quadratic. So what we want to do is take this general form and rewrite it in the standard form. And to do that, we're going to use a technique called completing the square. And if I remember correctly, I think there was only one of you that came. This was a lesson first semester that was a Fun Friday enrichment lesson that I gave, and Zariah was my only student who came to that. So this will be a rerun for her, but brand new for the rest of us. So completing the square, I'm going to start with a geometric analogy. So what we have here, we'll start with a square. And I'm going to say that this square has dimensions x by x. But then I want to add to this. So let's say we want to add 10. So now I no longer have a square. I have a rectangle, which would be an x by x plus 10. So if we expanded that, that would be x squared plus 10x's, right? This is worth x squared, and this rectangle would have dimensions 10 times x, or 10x. To complete the square, both geometrically and algebraically, what we do is we cut this in half. So I will make this a rectangle that is no longer 10 units, but 5. And then I take this piece here and I reallocate it up here. So at this point, I still have the same area. I just have it in a different location. Now, to get this to be an x plus 5, by an x plus 5 square, I need to complete the square. Because right now, this is missing. I took the green one and put it over here. So to complete the square, that would have a dimension of 5 by 5. So we add that 5 squared, and then we would have an x plus 5 squared, like we had in that first warm-up problem, a perfect square binomial. This is completing the square. So now let's do that algebraically. So what we do is we take half of this 4. So I have x squared minus 4x, and I add half of that linear term squared, just like I cut the 10 in half and then squared it. But that changes, as we saw, that changes the area here physically. So if I don't counteract that, I am going to change this quadratic. So then I also have to subtract off that same amount. Keep everything even, Steven. Now I can rewrite this as the quantity x minus half of 4 is 2 squared. And then I'll just do my algebra here. I have 2 minus half of 4 is 2 squared, which would be 4. And so now we can see how we could go from our standard form to our vertex form. And we do that by completing the square. Okay, our next one. What we want, though, this one's a little bit different, is we need a leading coefficient of 1. Well, that's easy enough to do here. You would have 2 quantity x squared minus 4x. And I'm going to put that minus 48 all on its own because I'm really concerned about these first two terms. I'll do the same thing I did up top. We should get the same results. I have an x squared minus 4x plus 1/2 of 4 squared. And then we added it here, so we're going to have to subtract it as well. And then I have the plus 48. Now here we have to be careful because what actually we are adding is 2 of these quantities. So in this time, I'm not just adding 4, I am adding twice that. Oh, and I screwed up. My bad, I forgot to take this out. So I'm only taking half of 2. I'm sorry. I'll fix my mistake. So half of 2 would be 1. I would square 1, but I'm doubling it up. So I have to subtract a total of 2. Then I rewrite what's inside the parentheses here as an x minus a 1. Half of 2 is 1. Quantity squared plus 40, or that's a minus, my bad. Gosh, I'm really jazzing this one up. Minus 48, so minus 50. All right, one more. We can bring that over if we wanted to make one side equal to 0. That's what we usually do when we try to solve quadratics. The leading coefficient is already 1. So I have x squared plus 8x plus 1/2 of an 8 squared. Then I have to take away 1/2 of an 8 squared and add 1 to it. We rewrite this as a perfect square binomial. This time we're adding x plus 4 minus, this is 16. One equals 0. So this would be x plus 4 quantity squared minus 15 equals 0. Okay, again, not really solving. I could use this technique to solve. It's a good technique to solve quadratics that are in standard form. However, I'm just using it to rewrite. All right, so pause the video and you give it a try. Okay, if you aren't getting those correct, then you need to meet with Ms. Fasola between 2 and 3 to get some extra help. All right, so now we're going to use that technique we just practiced to rewrite the general form of our circle equation into the standard form, and then we can identify the center and the radius. So here we have to gather up the x terms and the y terms, and then see if that constant that they gave us will help complete the square out of one of these two, and it does. So I'm going to associate that with the y. So I have x squared minus 4x. I'm going to leave some space to complete the square there, plus y squared minus 6y plus 9 equals 0. This I can right off the bat rewrite as y minus 3 quantity squared. And now I'll work on completing the square here. I want to add half of 4, which would be 2 squared. So I'm adding 4, and then I also have to take away 4. And I rewrite this as x minus 2 quantity squared, a plus y minus 3 quantity squared, and then we'll move that 4 over there. Now we can see our center is at 2, 3, and the radius is the square root of 4, or 2. And our x's and our y's. This one, I could maybe use part of that for in one of these two, or I can just move it over to the other side for the moment. All right, so I'll have 2 x squared minus an x, and then I'm going to leave space to complete the square and then subtract off what I added for that. And then I would have 2y squared plus 2y. So I'm dividing that by 2. Leave a space for completing the square and subtracting whatever I added equals negative 4. I'll take half of 1, which is 1/2. So I'm adding 1/2 squared, but I'm really adding double that. So that would be 1/4 times 2, or 1/2. And here I'm taking half of 2, which would be 1, squaring that to get 1, but I'm really adding 2 because I'm doubling that. So I have to subtract off 2. Now I'm going to rewrite this as 2 parentheses x minus 1/2 plus 2y plus 1 plus 2 equals -4. I think we want to divide everybody by 4. Or by 2. God. Well, I can move this over first. You know what? Let me just restart this whole thing because I'm running out of room. Sorry about that. Okay, so 2x squared minus 2x plus 2y squared plus 4y plus 4 equals 0. Got this 2x minus 1x. Take half and square it. So that would be 1/4. 2 1/4 is a half. Take out 2y squared plus 2y plus 1 squared, but that's really a 2 squared. So 4 equals 0. 2x minus 1/2 squared plus 2y plus 1 squared. And then we would have a -2 minus 1/2 plus a 4 equals 0. All right, let's move everything over here. That would be a -4 plus 2 plus 1/2. I think this should be a minus. And then we'll add that over here. I would combine these like terms. 4 plus 2 is 6, 6.5. And then now we want to take half of everybody. So this would be x minus 1/2 squared plus y plus 1 squared equals this would be 13 halves times another half, which would be 13/4. So our center here is 1/2, comma, -1, and my radius is square root 13/2. It's one more, and then there'll be a couple for you to try. Here I've got 5x squared and a 20x. and only one y term. So that's less work for us. Factor out the 5 to get x squared plus 4x's. Take half of 4, which is 2, and square it. But that's really a 4 times a 5, or a 20, so I have to take away 20, or you could think about adding 20 to the other side. 35 plus 20. Then I've got 5 times just y squared. Now we would divide everybody by 5. Combine these like terms. Rewrite this as x plus 2 quantity squared. And we get x plus 2 squared plus y squared equals 11. Our center is at -2, 0. Our radius is square root of 11. All right, time for you to pause the video and go ahead and give this a try.